Welcome back to Calculus 1. This is still Chapter 0, the preliminaries. We're working on Module 0.1.3. This is homework number 1. The solution to this problem will vary depending on your choice for x. My choice for x will be 1.25. So again, we start out with a function f of x, which is 4 minus x squared. And we need a point that is closer to the point 1,3 than the previous point that we used, which was 1.5 comma 1.75. Okay, let's go ahead and take a look at the graph. So this is just a quick sketch of what that guy looks like. So here's 4, here's the value 2. Now here's 1, and so we know that if we follow that up to the line, the function value at 1 is 3. And that was the point that was in question, and so we're getting a secant line through that point and another point. Now in the last problem we picked 1.5. We drew it up, we came over, we had a height value of 1.75. And so there's a point there. And then we went ahead and we drew through, a secant line. Now what we want to do is we want to move closer to the point 1 comma 3. So I used 1.25. I split the difference. You could use anything you want that's between 1 and 1.5. Now what we need here is the height value so that we can get a second point. So what is the function at 1.25? Well, this will give us the height value. So we'll take 4 minus 1.25, and if we do the computation out there, so 1.25 squared gives me 1.5625, and so if I do the subtraction there, I get 2.4375. So what? So what are we trying to do? Well, remember, that's the height value of this point. So now we've got the full point. It's 1.25 comma 2.4375. So I've got my second point. And so we want secant line, I believe this is secant line number 3. To figure out secant line, we need the slope. So if you want to get the equation of a line, you need the slope and then the intercept value. So if the slope is the change in y over the change in x, well, what is the change in y? Well, that's this length here on the y-axis is basically the difference between our height value of 3 and our height value of 2.4375. So if I grab these 2 points, the change in the y value is going to be 3 minus 2.4375. That's this guy minus this guy. Now we have to be consistent. We use the top, so we have to use the top here. So we're going to go 1 minus 1.25. Now the rest of this is just computation here, but what you should realize is that the slope is negative. So when I do my computations out, I need to get a negative value. If you mess up the order, you're going to end up getting a positive value. And so that'll help tell you that you obviously did it wrong. So when we do the computation out, it looks like it's going to be negative 2.25. Okay, so that's the slope of that yellow line. But to get the whole equation, we need the b value. So we have y is equal to mx plus b. What do we know? Well, we know this guy. It's over here. So we can just plug that guy in. Because the slope stays constant along the line. So we've got y is equal to negative 2.25x plus b. We have the x and the y values. We can use either point we want. I'll use the top point here because it's easier to work with. So 3 is equal to negative 2.25 times 1 plus b. And if we go ahead and we do the math out here, we're going to get a b value that's equal to 5.25. So that gives us our full equation. The equation of the secant line is y is equal to negative 2.25x plus 5.25. Now let's go ahead and grab our graphing software here. So now I'm going to plot the point 1, 3. Let's plot the equation of the line. Okay. We're also going to need that other point that we just found, right? So the 1.25, what was it here? 2.4375, I believe. Okay, so there they both are. Let's click on them. Yep, there they are. Now, maybe you should zoom in here just a little bit. So let me grab this button here and we'll zoom in a couple times and refocus it. So these 2 points that we're looking at, we want the equation of the line that goes between them. That's the secant line. Well, we found the secant line to be negative 2.25. I'll need to put an x in there. Hang on, let me go back. And if you notice, that confirms our thought that that is the actual equation of the secant line. If I would have graphed my secant line, it would have looked completely different. I'd have known I'd done it wrong. So if we zoom in, again, we can just take a look and we can see that those two guys share that common line.